I'm going to show you how we will be able to prevent double payment with this distributed lock algorithm. Between two network switches, some other process can execute a wrong release or wrong delete operation or wrong release operation of the lock. That's why we're going with the Lua scripting. So let's just discuss 5 use cases now. Okay, the first use case is using this kind of distributed locking algorithm. What you can do, you can prevent duplicate job execution. Welcome back to the channel. So in today's video, we are going to discuss about an interesting use case. We are not only going to discuss about it, but also we are going to implement one algorithm using Redis, which will help us in preventing double payments. Let's assume we are designing or developing a payment system like Razorpay or something like that. So preventing double payment is a crucial element of that entire application. So today we are going to understand about what are distributed locks, how can we implement distributed locks using Redis to handle this kind of use case like preventing double payment. Along with the preventing double payment wala use case, we are going to discuss 5 more other use cases. Along with distributed lock algorithm, we will also understand about Lua scripting. How do we use Lua scripting to ensure atomicity of a particular transaction? All those things we'll see with real code examples. So stay tuned with me. Alright. Okay, so to start with, what I'll do, first I'll try to implement the algorithm, because once we look at the code and once we understand the code, then we'll be able to then relate it with all the 5 use cases that I'm going to discuss. In this code only, we'll be able to understand what is distributed locking, how to implement distributed locking, what is Lua scripting, how to use Lua scripting to ensure atomicity of any transaction. All that with using Redis. So without further delay, let's start. So for now, what I have done, I have already started my Redis stack using Docker. So Redis is already running in my system. If I go to the dashboard, yeah, you'll see that my Redis stack is already running here. All right. So we have both the ports open, and this is where the Redis UI is present, right? As you already know, this is my 4th video on implementing use cases with Redis. So you can check out other videos in my playlist. You will definitely find them interesting. We have implemented leaderboards. We have implemented 4 rate limiting algorithms using Redis. So those will be very useful and handy tools for you to check out. Okay, so please check that out. So this is the UI for our Redis store, and in the port 6379 the Redis server is listening to. So we are now ready with the Redis server which is running. So I've used this command to start my Redis stack in my local. So you can check that out. Now what we will do, I'm going to create a folder called what shall I call? Distributed lock, because this is the distributed lock. This is the core of this algorithm that we are going to test. Let me just name it as log.js. Alright. Now what we are going to do here, as we know, as we have been following in all of our previous Redis videos, I am going to use IO-Redis package of npm. If you go, you'll find this IO-Redis package. This is the client that we are going to use to interact with our Redis server. Alright. So now what I will do, I'll just simply create a Redis client. IO-Redis. Once I'm ready with this, what I'm going to do, I'm going to create a new Redis client. By default, I'm not passing any host or port information here. By default, it will connect to localhost and the port is 6379, because my container is running in this port, as you can see here. Right, 6379 port, my Redis server is running on. So I'm ready with the Redis client now. Now what we'll do, we'll create 3 functions. So in order to implement distributed lock, there are 3 components. The first one is a logic to acquire lock. Before you want to perform any restricted or atomic transaction, you need to acquire a lock first. Then you need to have a logic for releasing a lock. Alright. And then between these 2 things, acquiring lock, there will be some critical tasks. So for example, payment is your critical task, one of the critical tasks, right? So we'll implement these 3 steps now one by one. First, let me just create a function for acquiring the lock. So I'll create a function called acquire lock. This is my function. Let's say we'll run it in async manner. And here I'll just take few inputs. First one is the lock key. Then what is the value of the log? I mean, what is the value I'm putting? Then there is TTL. So this is the function structure. Now inside this, what we will do? We'll first check if I have my log key set or not. I mean, if the log is acquired by anyone else or not. That's what I'm going to check. So what I'm going to check, I'll just check if log key is set with log value. No, it's not like that. It's basically with this command we are trying to basically set the corresponding value log value to this log key. That means मैं बोल रहा हूँ कि log डाल दो अभी, ठीक है? For this key, is logged. But we won't just blindly write it like this. We won't blindly put a lock on the log key. What we are going to do, we are going to pass two more parameters to it. Px, then there is ttl. I'm going to explain each of the parameters one by one. So this will return a boolean flag, right? That means log is successfully. Now let me just explain you a bit about this two parameters, nx and px. Now if you go to the official documentation, what does it do? See, without these three things, we know that Redis set log key basically sets a given value for a given key. It's nothing but like, let's say key is equal to 10. This is what it sets blindly. But if I pass these two parameters, what does it mean? If I go to the documentation here, if you go to the documentation for set, what does set do? Nx means only set the key if it does not already exist. That means if the key is already present, that means someone has already acquired that log. So you cannot acquire this log further. So if this is the case, do not allow overriding this key. That's the first thing. That's the first thing we have put here. If exists, then only write. What is the px? Px is used to define the expiry time of the log, because you cannot you cannot hold that log infinitely, right, or indefinitely, right? You have to release that log. So that's why we use the px parameter, and along with that we pass a parameter number of milliseconds to wait before releasing the log. So this is the time to live. TTL is nothing but the time to live. That means I am instructing that this log will be acquired by whichever process is calling this function. That process will hold this log for this TTL amount of time. So this is about the simple acquire log function. Now the most critical part is about the releasing log, because acquiring is simple. If lock is present, lock is open, no one has taken it, you just take it, right, and lock it. But releasing is where the interesting things happen. It's not very simple like you just check if lock is there, then just delete the key or release the key. It's not like that. This is where the Lua scripting will come into picture. Now how? Now let's just write RELESS. Let me write this release log function. So this will also be a async function, and we will have log value. All right. Now what does this what will this release key function will do? Here, as I mentioned, I will write a Lua script to ensure that the log is released at once and only by the owner, not by anyone else. What does that mean? Now first just let define the script first. How do we define a Lua script? It's just plain string you define like this. Alright. What is Lua script? I'll explain first. You just see the script. How does it look like? Okay. Redis call. We'll do get. Get of what? Check this log key. Okay. What is all these things I'm going to explain. Okay. Key is one, all these things. If redis.call get keys is equal to argv1, then what I'm going to do, return redis.call del keys of 1, delete that key, else return 0, then end. This is how we write a Lua scripting. What I am doing here, basically I am performing two Redis operations here. Just like we performed one Redis operation here. What did it do? This basically makes a network call, because Redis is finally a server and this is a client. This code that I'm writing, it's a client. So there is a client, there is a server, right? I just show you somewhere. See, if you see here, I have Redis. This is my Redis server, right? And then I'm writing the code, the Node.js code that I'm writing. It's a Redis client, right? It's a client to this. And this basically makes all those calls like set, then deal, get, whatever command you run. This is passed or interacted or sent as a network request to this Redis server, which is running in port what? 6379. Alright. Just like this, in the scripting, what we are doing, we are basically doing two more operation. Redis.call, we are getting the value of the key, then deleting that key. But this is different. This is not like a network wala call, because that's the beauty of Lua scripting. When you pass a Lua scripting, when you create a Lua scripting that like this will be executed at once directly on the server. This entire script, okay, that entire script will be executed on the server here. Whatever I have written here, right? This script, Lua script, that will be executed at once in atomic manner. It's not like it's not two different network calls. All right. So had I written it like this, for example, अगर मैं इसको ऐसे लिखता, I could have written it like this also. I mean, simply I could have written like this, ki get the value of the key. Okay. If lock value is equal to my value, I mean lock value is equal to my value, whichever is value, delete that key. If you see, this is and this are look similar, but they are different, because here we are basically making two network. This is one network call to Redis server. Okay. And this is another request, and this is another network call to Redis server. So two different network calls I am making. But with the help of Lua scripting, what will happen now? The entire script, all the script will be run at once, and this will run on the Redis server itself, as I told you. Now if I just show you the definition, Redis guarantees the script's atomic execution. While executing the script, all server activities are blocked during the entire time. Nothing else are allowed. No write, no read, nothing is allowed until the entire Lua scripting is done. That's why it is very powerful tool to provide atomicity while running a given logic. Alright. This semantics mean that all of the script's effects either have yet to happen or had already happened. Either it will happen at once or it won't happen at all. That's how it works. It's just like a transaction, database transaction that you see. So using this atomicity of the Lua scripting, that's what I am writing here. This is a Lua script I have written, right? Now what I will do, I'll just execute this Lua script on the Redis server. Alright. So in order to run that script in the Redis server, what I'm going to, I'm calling the eval method of the Redis client. I'll evaluate a script. Alright. So I'm going to evaluate a script. What are the number of arguments I'm going to pass? I'm going to pass one argument to the script, and the argument is log key. And what is the value of the argument? It's log value. So this is how the arguments are passed to this Lua scripting. So key is equal to 1 is nothing but this, and arg is equal to 1 is nothing but this. If I had to pass two arguments, this will be basically my arg1, this will be my r2, then value 1 is the value of arg1 and value 2 is the value of r2. Then accordingly you can access the dynamic variables here, alright, in your Lua scripting. But in our case we need just only one argument, so that's why I'm passing it like this. Now you understood why it is important to release the lock using Lua script rather doing two independent network call. क्योंकि अगर ऐसे लिखते हैं हम लोग कोड, अगर you just think कि when this ran and this runs, these are two different network calls to the Redis server. In the meantime, there is a there is a buffer time, right? Or there is a context switch that can happen. So some other process might come into the picture and they can just acquire or delete that key. Even if I am not the owner, some wrong owner can come and he can delete the key. So that can be disastrous, right? Let's say I have acquired that lock to perform a transaction, but when I am withdrawing money from the ATM, I have locked my door. Someone else comes with his key and opens the door and sees my password. That's not safe, right? So only I should be able to unlock that door, and then I can pass on that key to any other person, and he can then use the ATM or lock it and do his transaction. So that's the reason we are not going with this approach, because it involves two different network calls, and there will be context switch between two network calls, and between two network switch some other process can execute a wrong release or wrong delete operation or wrong release operation of the lock. That's why we're going with the Lua scripting. I hope it was a bit detailed discussion I made about Lua scripting, but I hope you understood about the Lua scripting in detail and why we are using it. Now we are ready with both the critical parts of our distributed computing, right? What I'm going to do, just write a sample code, perform some sort of critical task. So the critical task may be payment activity, right? It can be anything. How you want to perform the task, it's up to you how you want to do. Okay, first what I'm going to do, my log key is, let's say, this is my log key. Log value, you can put something, let's say for now you can have a new date. Okay, that's fine. You can store this to as a strong string as the value, and my TTL will be, let's say I want to acquire the log for 5,000 milliseconds, which is nothing but 500 milliseconds. Okay, now what I'm going to do, if await, before performing any transaction, I'll first try to acquire the log, okay, with the given TTL. If I am able to acquire the log, then only I can print something like, yeah, log acquired, performing a critical task. Wait till the end. I'm going to show you how you will be able to prevent double payment with this distributed log algorithm. Then what we can do, you can try some sort of, you can implement a similar, you can write your own code to handle critical tasks, because there are multiple use cases. Just like I told, I'm going to discuss 5 such use cases, critical use cases or tasks. You write your logic, which will be performing here. So for now, as the critical task, I'll just run a set timeout. Okay. In the set timeout, what I'm going to do, I'll just run a set timeout, which will resolve after 3 seconds. Okay. And finally, I'm going to release that lock which I had acquired. Okay. And we can print something like lock released. This is what we have done. So this is my code to perform a critical task by acquiring a lock. If I am not able to acquire a lock, I'll just simply print could not acquire lock, some other process already acquired it and using it. If I am not able to get the log, so this is what I am going to print in the message. Now what I am going to do is just call this function and we'll see how it is happening. Okay. Now what I am going to do, I'll just go to documents, personal, python.kesari, Redis distributed log. What I'm going to do, I'll just run log.js. Log acquired. The log is valid for 5 seconds. Log is released after 3 seconds because the task is completed. Alright. And we are done with our function now here. Okay. Now what we can print here. Here I can print critical task is completed. Now if I just run it, and by the time I'll just open this so that you can see the lock being acquired. Yeah, lock has been acquired. See, the life of this lock is it's gone after 5 seconds, right? If I just increase the life of the lock to, let's say, maybe 15 seconds, you'll be able to see lock is acquired. Okay, okay, the task was completed of 3 seconds. Let me just change it to 10 seconds. I mean, the task takes 10 seconds to be closed, right? So I'll open two tasks so that two processes can be run in order to get that lock. So here I'll first run the node log just, and here also I'll just see. If you see, this process has already acquired that lock, so that this process, the another process, could not acquire the lock because the lock is being used by this already. Now this process is already completed, it released that lock. Now if I run it here, you see lock has been acquired by this process. Now if you just try it here again, it will then fail to acquire that lock because, and it won't be able to acquire that lock till 15 seconds, until the lock is released by this task. Not 15 seconds basically, until and unless this critical task is completed. 10 seconds is completed, you won't be able to acquire that lock again. So this is how the distributed locks work, and we manage atomicity between a critical transactions between multiple instances of process. Let's say this is one server, this is one microservice, and this is one microservice. If both of them depend on same resource, you can put locks using this kind of distributed locking algorithm. All right. So I hope you understood about the implementation and how we are going to use it. Just as a final test, let me just test it just for your clearer understanding. I'll acquire lock here. For 10 seconds, it won't be able to acquire that lock. See, it is already acquired. It is still performing the task. Once it is done, now if I I'll be able to acquire that lock. So this is how this distributed locking works. Okay, now that you understood about this distributed locking using Lua scripting and all these things, and why we used Lua scripting, I already explained in detail. You must not be having any doubt. If you have any doubt, you can put it in the comment section. I'll discuss. Okay. Now what I'm going to do, we'll discuss how do we prevent payments, duplicate payments using this algorithm. So let's just discuss 5 use cases now. Okay. The first use case is using this kind of distributed locking algorithm. What you can do, you can prevent duplicate job execution. For example, in a distributed system, multiple workers may pick up the same job which you don't want to. If one job is already picked by one worker, you don't want another worker. Workers are what? They're just instances of server or instances of script which do some kind of job. So which can cause duplicate execution. So for example, a cron job sending email notification might run on multiple servers sending duplicate emails. So in order to avoid that, you can have this kind of things. Obviously, we won't release lock like this. We'll call our release lock वाला जो implementation था उसको हम यहाँ पे call करेंगे. So this is how you acquire that lock. If lock is not written, you perform your critical job here. You release the lock. This is one example. Now the second example is to have the leader election. When we are working with distributed systems, leader election is a by default thing that you need to consider. If you have database cluster of 3 nodes, one node fails, the master node fails, or you have 5 nodes, one master node fails. So among that rest 4 or rest 3 node, one has to be the leader. So while acquiring the leader or trying to be the leader of that cluster, you can think about implementing distributed locking, because without proper locking, multiple nodes might assume leadership, because if they acquire lock, they will say that I am the leader. So with both two leaders present in the distributed cluster, it's a disaster, right? Because only one leader should be there in a distributed cluster. So this is how you can implement the leader election. For example, you acquire that lock. If leader is there, I am the leader, else it's not, another node is already the leader. Just like what we saw here, right? If this has acquired the lock, another process is not able to get that lock. That means this is the leader. You can think of like that, right? The next thing is ensuring atomic updates in e-commerce. For example, people are ordering a product very fast and you need to update a stock, right? So if already one process or one user has placed some order, so before the inventory is updated for that user, the next user's update won't be considered. So multiple users purchasing the last stock item of product might overbook inventory, obviously, right? Because you have only one item left, but 2 people were able to book that iPhone. in the big billion day sale. So that's a disaster. So without locking, two users might buy the same item before even the system updates the stock. So this is where you can think of implementing distributed locking to avoid this kind of cases. You'll acquire that lock, you lock that product, acquire that lock, then decrement the stock of that product. Alright, then you release that lock. Again, as I told, you will call a release वाला function जो है. ठीक है? This is the another use case. The fourth use case is distributed caching with safe updates. For example, if there are two services which are using the same cache server, or you have a distributed caching, right, where multiple servers might try to update the cache entry in the same instance of the, let's say, Redis or Memcache simultaneously. This may lead to obviously stale or inconsistent data. In order to handle that, in order to ensure safe updates of in distributed caching architecture, you can think of using this distributed locking. For example, updating a user profile cache might result in race condition. That's why what you can do, you first acquire that lock to update a particular information about that user. If lock is acquired, you perform all your updation as you want. You perform your DB transaction, you perform your Redis transaction, it's up to you. Then you just release that lock. Now the final thing is, the most interesting thing, how do you prevent double payments? If a user accidentally clicks twice on a payment button, it can lead to duplicate transaction. You don't want the user to pay twice for a single transaction, right? So race condition payment gateway can cause money to be deducted twice, which is wrong. So in order to handle that, same thing we can do, we'll acquire that lock. Let's say for a given order ID, this is my order ID 5678. For this, I'll first acquire a lock. I'll do the transaction, okay? All transaction, doing the transaction is the critical part. For example, this is the critical transaction. Payment processing we are doing. If lock is not required, obviously we'll mark it that already one payment is being tried. For the same order ID, one payment is already being tried. So this is a duplicate payment that we are noticing. So you can just abort the transaction and return it without processing further. But if it is the first payment that you are trying, you can process the payment, which is the critical task. Then release your lock using our release lock function, right? So that was about today. Video थोड़ा आज लंबा हो गया. This video became a little bit lengthy, but I hope that was worth it. I was able to explain you in detail how to implement distributed locking using Redis. It's a very useful use cases that you are going to definitely use in your life, in your career, somewhere at some place. Okay, so please go through this and try to implement your own thing using distributed locking, and let's come up with all other different use cases that you can think of about implementing distributed locking with Redis. So I've discussed about 5 use cases. I want you to come up with more use cases and discuss me with the chats. So if you like this video, if you understood something about this concept, please drop a like. Let's target for 50 likes for this video, and let's target to reach 3,600 subscribers by the end of this month. So keep supporting. So if you have any questions or any doubts, let's just discuss in the comment section. So thanks for watching this video, and I'll see you in the next one. Thank you.